So here's another example. If we have a quadratic function where we actually have a b, so it's x squared plus 2x minus 5. So we're going to start by identifying our a, b, and c since it's already in standard form. Okay. So our a is our 1, our b is 2, and our c is negative 5. One thing to remember is that if there is no coefficient, the coefficient is 1. So next we're going to find our x-coordinate of the vertex, so we can start our chart. And it's also the equation of the axis of symmetry as well. Right? It tells you where the center of our parabola is. And so, so let's go and plug in numbers, right? So negative 2, that's negative b, over 2 times a. So 2 times 1. So that's going to be negative 2 over 2 is equal to negative 1. Okay, so our the x-coordinate of the vertex is negative 1. So over here on our vertex, we're going to start with negative 1. And so that means for our point to the left of negative 1 is going to be negative 2. And then to the left of negative 2 is negative 3. All right. So starting at our x-coordinate of the vertex, which is here at negative 1, to the right of negative 1 is 0. And then to the right of 0 is 1. So that's how I get my x values for the symmetrical table. So here we're going to say y is equal to x squared plus 2x minus 5. Okay, so we need to go ahead and figure this out. So you can get a calculator and you can get some scratch paper on the side. So maybe I could use this scratch paper here on the side, right? So the first one is negative 3 squared plus 2 times negative 3 minus 5. So negative 3 squared is positive 9. 2 times negative 3 is negative 6. And then we have negative 5. So that's going to equal to negative 11. 9 minus 11, right, which is negative 2. And now let's do negative 2. So we have negative 2 squared plus 2 times negative 2 minus 5. So negative 2 squared is 4, positive 4. 2 times negative 2 is negative 4 minus 5. So these two 4's cancel out, and we're just left with negative 5. Alright, let's try negative 1. And so negative 1 is going to be negative 1 squared plus 2 times negative 1 minus 5. Negative 1 squared is 1. 2 times negative 1 is negative 2 minus 5. So it's going to be negative 6. Right? Here we have negative 7. So it's 1 minus 7, which is negative 6. Okay. And so we know that it's symmetric. Right? This parabola is symmetric. So here for the point to the right of the axis of the vertex, it's going to be negative 5. And we know that it's symmetric, so this point 2 units away from the vertex is going to be the same as this unit 2 units away from the vertex, so it's going to be negative 2. All right. So once we get half the chart done, then we can just go ahead and fill in the other chart. Half. We don't even need to calculate, right? But you need to make sure that your calculations are correct on the first couple of points. Okay, so let's go ahead and draw our graph then. So the first one, the order pair is negative 3, negative 2. Negative 3, negative 2 takes me here. Negative 2, negative 5 gets me to here. Negative 1, negative 6 takes me here. 0, negative 5 is here. And 1, negative 2 is here. Right. So I am drawing my parabola like so. And what's our domain? Well, we talked about this earlier, but the domain is all real numbers, right? So on all of these parabolas, on all of these quadratic functions, our domain is going to be all real numbers. And what's the range? Well, the range is the possible y values, right? And so since this parabola is opening upwards, all possible y values are going to be from positive infinity to 4, right? So I'm going to state all y such that y is greater than or equal to negative, oh, that's not a 4, that's a negative 6, is greater than or equal to negative 6.